Hello students, welcome back to Sir Rasayan. In this lecture, I am going to explain some questions on nucleophilic substitution reaction. Question 1. Explain which nucleophilic substitution reaction will occur and which one will not. Two reactions are given. Now how to solve this type of question? Now see, this is schematic representation of nucleophilic substitution reaction. This is substrate and this is product. This is attacking nucleophile. This is leaving nucleophile or leaving group. So in nucleophilic substitution reaction, what happens? One nucleophile is substituted by another nucleophile. This is nucleophile, this part is also nucleophile. So this is substituted by this nucleophile. Now remember, these are attacking nucleophiles and these are leaving nucleophiles or leaving groups. Another thing you have to remember, nucleophilicity is proportional to basicity. Nucleophilicity is proportional to polarizability. Nucleophilicity is proportional to basicity means with increasing basicity, nucleophilicity increases. Another thing, leaving group property is inversely proportional to basicity. That means with increasing basicity of the species, its leaving group property decreases. Or with decreasing basicity, leaving group property increases. And with increasing polarizability, leaving group property increases. Now one by one, two examples we will see. In this example, this is your substrate, this is your attacking nucleophile. This is your attacking nucleophile. And this is your leaving nucleophile, means leaving group. So it leaves and it attacks, we are getting this product and this leaving group cyanide. So in this reaction, if it takes place, cyanide is acting as leaving group and iodide is acting as attacking nucleophile. Whether this reaction is possible or not, we have to check. Now see, here we have to compare the basicity of cyanide ion and basicity of I minus. Cyanide and I minus. So its conjugate acid is HCN and its conjugate acid is HI. Just we are adding H plus to Cn minus and I minus. If you compare the acidic strength, HI is stronger acid than HCN. This is weaker acid. So this is stronger. This is weaker. So if this is weaker acid, then its corresponding base is stronger. And if it is stronger acid, then this corresponding base is weaker. Here corresponding base is stronger because HCN is weaker acid. So this is stronger base. So cyanide is stronger base than I minus. We know leaving group property is inversely proportional to basicity. If cyanide is stronger base, then it is poor leaving group. So cyanide here is poor leaving group. Therefore, this reaction is not possible. To make it possible, what we have to do here, we have to use a better leaving group. Since cyanide is poor leaving group, so this substitution reaction is not possible. So what we have to see, whether the leaving group is sufficiently good leaving group. In the next example, azide. This is azide ion. This is attacking nucleophile and I minus is leaving group. We know I minus is highly polarizable, therefore it's a good leaving group. So it leaves and it attacks here. So this reaction is possible because iodide is good leaving group due to its better polarizability. So here what you have to check, whether these leaving groups are good leaving group or not. Next question, ROH means alcohol reacts with NaBr in the presence of sulfuric acid to give RBr. Why is H2SO4 required? Now it is given ROH reacts with NaBr. Alcohol from NaBr you can write Br minus is coming, and by this reaction we will get RBr plus OH minus hydroxide ion. Now see here what is happening. This is your substrate. This is attacking nucleophile. This is your product. This is your product. This is substrate. This is your attacking nucleophile, and OH minus at the end we are getting. So OH minus is substituted by Br minus. So this is nothing but nucleophilic substitution reaction. Comparing this reaction with this general nucleophilic substitution reaction, we can see here with alkyl group leaving nucleophile is attached. So from here OH minus is leaving nucleophile. OH minus is here leaving group, and this is attacking nucleophile. So Br minus is attacking nucleophile. Both OH minus and Br minus both are nucleophile, but one is leaving nucleophile, another is attacking nucleophile. Their properties are different. This nucleophilic substitution reaction is possible if attacking nucleophile means Br minus is more nucleophilic than leaving group or leaving nucleophile. Here leaving nucleophile is OH minus. Then only this reaction is possible. Or you can think in this way that leaving group, here leaving group is OH minus hydroxide ion. Leaving group should be a good leaving group. So we have to check whether OH minus is good leaving group or not. How we will check? If we compare the acid strength between water and HBr, which one is more acidic? This is mineral acid, so this is more acidic than water. Now we have to compare the basicity of conjugate bases. Its conjugate base is Br minus, just remove H plus from here. Its conjugate base is hydroxide ion. Remove H plus from here. Now, since this is strong acid, this is weak acid, water is weak acid. So, its conjugate base, corresponding conjugate base is weak base. And since it is weak acid, water is weak acid, corresponding conjugate base is strong base. So OH minus is stronger base than Br minus. Therefore, OH minus is stronger nucleophile than Br minus. If you compare the nucleophilicity, then OH minus is stronger nucleophile than Br minus. So this substitution is not possible if attacking nucleophile is much more stronger than leaving nucleophile. Then the reaction is possible, but here leaving nucleophile is much more stronger than attacking nucleophile. So this reaction is not possible. Another thing we know, leaving group property and basicity are inversely proportional. Since OH minus is stronger base, since it is stronger base, therefore it is poor leaving group. If this leaving group is poor leaving group, then the reaction is not possible. So how to make it possible? We have to convert this poor leaving group into a much more stronger leaving group. How we will make? In the reaction medium, we have to add sulfuric acid. What is the role of sulfuric acid? ROH plus H2SO4. What will happen? H plus will protonate this OH and it will form ROH2 plus HSO4 minus, because sulfuric acid will dissociate to form H plus and HSO4 minus. That H plus will protonate this OH, so we will get this protonated alcohol. Then what will happen? Take this protonated alcohol and in the medium from NaBr, Br minus, attacking nucleophile is there, attacking nucleophile. Now here leaving group is water. Which is leaving group? Here leaving group is water. And since we know leaving group property is inversely proportional to basicity, we know water is poor base. Therefore, it is a good leaving group. Good leaving group. So, we are converting a poor leaving group into a good leaving group. And then what will happen? Substitution will take place. This will substituted by this. We will get RBr plus water. So, by adding H2SO4, we are converting a poor leaving group into a good leaving group, and reaction takes place easily. Here, if R group is tertiary alkyl group, it will be SN1. If it is primary one, then the reaction will be SN2. In this video till this, if you like, please subscribe. Thank you for watching.